Good morning, my dear students. Welcome to my physics class. Our today's topics are scalar and vector quantity, equations of motion. Let's start now. Our first topic is scalar and vector quantity. Already we know physical quantity. Something that can be measured is called physical quantity. Example, we can measure mass, it is a physical quantity. We can measure time, so time is a physical quantity. We can measure length, length is a physical quantity. Something that can be measured is called physical quantity or quantity. But we cannot measure happiness, sadness. Therefore, happiness, sadness are not physical quantity. Now there are two types of physical quantity, scalar quantities and vector quantities. Scalar quantities, the quantities which can be described by magnitude only, direction is not required, are called scalar quantities. Scalar quantities means the quantities which can be described by magnitude only. That is, this type of quantity can be expressed fully by its magnitude only. It has no direction, and direction is not needed to express this type of quantities. So these are the scalar quantities. Example, temperature. If you want to measure temperature, we can measure it, but we have to mention the magnitude of the temperature only, but no direction. Example, 30 degrees Celsius temperature or 250 Kelvin temperature. We need only magnitude, no direction. And mass means 5 kg, 10 kg, 5 kilogram rice, 10 kilogram potatoes. These are only magnitude, no direction is needed to express mass, temperature, density, speed, work, etc. So these are the example of scalar quantities. Now vector quantities, the quantities which require both magnitude and direction for their full description are called vector quantities. For the scalar quantities, we don't need any direction. But if we want to express the vector quantities, we need direction along with its magnitude, because only with the magnitude we cannot express this type of quantities fully. So direction is essential to express this type of quantities. Example, velocity, force, electric field, magnetic field, etc. Because for velocity we need a direction, for force we need direction, electric field, magnetic field, these quantities have direction. If we say a car is moving with velocity 50 meter per second, then we cannot say in which direction the car is moving. The car may move in north direction, south direction, east direction, west direction, or any other direction. But if we say a car is moving in north direction with 50 meter per second velocity, then it is complete. Easily we can say the car is moving in the north direction and with the 50 meter per second velocity. Here 50 is the magnitude of velocity and north is the direction of this velocity. That is, the car is moving in the north direction with 50 meter per second velocity. Similarly, force. Suppose a force is applied on a body in south direction, then easily we can say the direction of the force. Otherwise, the force may be in any direction, in north direction, south direction, upward direction, downward direction, in any direction. But if we mention the direction, it is complete. So these are the vector quantities. These are the basic difference. The scalar quantities have magnitude only, they have no direction, but for vector quantities they have both magnitude and direction. Now representation of vector. A vector can be expressed by an arrow sign. By this arrow sign we can express a vector quantity. The length of the arrow expresses the magnitude of a vector, and the direction of the arrow expresses the direction of the vector. The length from this to this. The length of this arrow expresses the magnitude, and the direction of this arrow is the direction of the vector quantities. OP vector represented by OP, that is a arrow sign, and its magnitude is represented OP or mod OP. A vector can be expressed by letter by the following ways. If you want to express or represent a vector by the letter, then you can use any one of these following. Now properties of vectors. Vector quantities require both magnitude and direction for their full description. That is, for the vector quantities both magnitude and directions are needed. A vector quantity changes if its magnitude or direction or both changes. That is, if the magnitude of a vector quantity changes, then the vector quantity will be changed. Or if only the direction is changed, then the vector quantity will be changed. If direction and magnitude both are changed, then the vector quantity will be changed. So if its magnitude or direction or both changes, then vector quantity will be changed. The addition, subtraction, multiplication, etc. of vector quantities cannot be done by simple algebraic laws. These are done by the laws of vector algebra. We have to use vector algebra for the addition, subtraction or multiplication of vectors. Now our second topic is equation of motion. Suppose an object is moving with initial velocity u and uniform acceleration a. After time t, its velocity is v and distance traveled by the object in this time is s. Here, initial velocity of the object is u, that is the object start to move with this velocity u, and its final velocity is v, and the object is moving with uniform acceleration. Here uniform acceleration means with constant acceleration, the velocity will be changed with a constant rate, that is the magnitude and direction of the acceleration will remain constant. That means this is the uniform acceleration. Here time is t and distance traveled in this time t is s. From this to this displacement is s. Now acceleration of the object is, acceleration is equal to final velocity minus initial velocity divided by time. Here time required to change this velocity from u to v is t. Here v is the final velocity, u is the initial velocity. Therefore acceleration is equal to final velocity minus initial velocity divided by time, and this is a is equal to v minus u divided by t. And after simplification, this is v is equal to u plus at. This is the first equation of motion. V is equal to u plus at. Our first equation, v is equal to u plus at. Now average velocity. Average velocity means the total distance traveled divided by the total time. If we divide the total distance by total time, we will get the average velocity. Here total distance is s and total time is t. So s divided by t is equal to average velocity v, and average velocity v is equal to u plus v divided by 2. Here two average of two quantities, here u and v, these are two velocities u and v. So u plus v divided by 2 is the average of these two velocities. Here two quantities, therefore divided by 2. U plus v divided by 2 is the average velocity v. And also we know average velocity v is equal to s divided by t. So we can write here s by t is equal to u plus v divided by 2, because here s by t is average velocity and u plus v divided by 2 is also average velocity. So we can write s by t is equal to u plus v divided by 2, and this is s is equal to u plus v divided by 2 into t. This is equation number 4, and it is the one of the equations of motion. V is equal to u plus at, already we have got it, and here s is equal to u plus v by 2 into t. Putting the value of v from equation 1 to equation 4, we get here v is equal to u plus at. From equation 1, the value of v is u plus at, and after putting this value v in this equation, that is equation 4, u plus v, instead of v we will write u plus at. Here s is equal to u plus v, v means u plus at, so u plus at divided by 2 into t. This is equal to u plus u twice u into t, twice ut plus a into at into t, at square divided by 2. This is equal to s is equal to ut, 2 cancel, ut plus at square divided by 2, that means half a t square. So s is equal to ut plus half a t square. This is another important equation of motion. S is equal to ut plus half a t square. Now putting the value of t from equation 1 to equation 4, here v is equal to u plus at, therefore t is equal to v minus u divided by a. T is equal to v minus u divided by a. Putting the value of t from equation 1 to equation 4, here instead of t we will write v minus u divided by a from this equation. So s is equal to u plus v divided by 2 into here t means v minus u divided by a, and after simplification u plus v and here v minus u, v plus u into v minus u means v square minus u square. We know a square minus b square is equal to a plus b into a minus b. So a plus b into a minus b means a square minus b square. Here v minus u into v plus u is equal to v square minus u square divided by 2 into a, or v square is equal to u square plus twice a s. Here v square minus u square is equal to twice a s, therefore v square is equal to u square plus twice a s, and it is one of the important equation of motion. And finally we got v is equal to u plus at, s is equal to u plus v divided by 2 into t, s is equal to ut plus half a t square, and v square is equal to u square plus twice a s.